Welcome to a 5-axis programming video. In this video, actually I should say 3+2 axis. So we're not really going to do any simultaneous 5-axis motion, but we are going to do 3+2, which is generally the bulk of what you're going to do in a 5-axis anyway, depending on, of course, where you work. But we're going to program this part here. And essentially what this is, it's a bar puller housing. Kind of give you a better idea. I actually have the solid here. So if you can take a look at the solid there. So essentially what we have is just basically a channel we're going to be making. We do have some slots down along the side, very shallow, just for some grease. Some tapped holes all around it, a little recess for a spring, some spring steel there. Okay, so let's look at how we're going to process this part. So that's the first step. Anytime you're programming something in 5-axis, you want to decide how you're going to process. What's the most efficient way to process this thing? And you have to think about the capabilities of the 5-axis, but also some of the drawbacks of the 5-axis. In this case, I think that the best way here would be, well, number one, what stock do we have? Okay, so for us, we have a bunch of 1 7/8 by 1 7/8 that was donated. So makes sense. We're just going to use that stock. It's a little bit of extra material to mill off, but we're not making a ton of these, so we can use that stock. We're probably never going to use it for anything else. So what it probably makes sense to do is to essentially hold by this face, so I'd be looking down on the part like this from my spindle. So if I was viewing this from the point of view of the spindle, I'd be looking down on it. So what I would do is mill around and mill this whole part out, so mill all the extra material around the sides of it, mill the slot, tap the holes, and we can actually tilt it in the 5-axis, tap these holes, drill and tap these holes, drill and tap these holes, and essentially we have all 5 sides done, with the exception of only this 6th side or the bottom, where we can mill the extra material off and then finish this side as well. Now, you may be wondering, can't I drill, tap, and do all these holes from this side? And the answer is, yeah, I can, with the exception of these 2 that I don't have access to. So I do have these 2 here, which I won't be able to access. You have to look at what's critical in this. So if I go back to my print, which is right here, so these holes here, these 2 tapped holes, those are essentially just a place to put grease in. So not super critical parts at all. This one here, this hole here, this is for a pin. It's actually for a roll pin, which is just for locating. And then these tapped holes are to actually connect the shank to this housing. And then this hole here is just a dowel pin hole that is going to limit the stroke of the jaws for this bar puller. So really the only thing that's critical on here, actually nothing is really that critical on here, but if I said anything was critical to maybe the outside dimensions and this slot, it would be this dowel pin hole, because it has to go with the functionality of the slot and everything. So that one I probably will drill and ream, based on the fact that you can see here it's a pretty tight tolerance. I'll drill and ream that one from the top. But then when I flip over, I'll probably do the rest of these holes on the second op. Another thing, so when we make things in the 5-axis, we are usually holding in a vise that has a dovetail in it. For this particular part, I don't think we need to use the dovetail. I think we can hold this part without it. We're not doing anything real heavy on here. And we'll control our step over when we're milling off that extra material, so that as to not put too much cut pressure into it. So rather than adding a third op, to put a dovetail on the part, we're just going to hold this with the jaws. That they actually have a serrated jaws that will grab into the material, and they hold extremely well. So there's no need to dovetail this. So we can finish this part in 2 ops. Okay, so without further ado, let's go ahead and get started. this down, and let's bring up MasterCAM. Okay, so I do have a solid, and I'm going to be working off of the solid. A lot of times I will work off solids for anything that I do in the 5-axis. Generally, I'm working off a solid. If I need geometry, I'll just create geometry from the solid. So I'm going to go to Open and go to my computer, and I'm going to try and find this. I don't have it up. So, Documents, and Bar Pooler. And I have to change my file type. So I'm just going to pick all files. And Bar Pooler, we want the housing. Okay, and right here is my solid file. And I just know it's my solid because I know what the icon looks like. The drawing file is actually this one here. So I'm going to pull that in. And of course it's going to bring that back up. Alright. Okay, so I have my solid in. Now the first thing I notice here is that my solid is not oriented correctly. Right? I want that channel there facing up towards the z-axis. So I'm going to need to do a rotate here. So I'm going to select this, and I'm going to select rotate, and of course it's not going to give me the correct. So if I go to top, this is my top view right now. So now the best way to rotate this would be from the right side view. So what I'll do is go to right, and now select it, and we can use our rotate. And I'm just going to make that 90. And I want to move it, not copy it. Check. Okay, so now if I go to top, alright, so now I'm holding it like this. Well, it's still rotated 90 out. I want it the long way, the long axis of the part to be aligned with the x-axis. So we're going to grab this again, and I'm going to do another rotate. And it already knows because last time I did a 90, so I'm going to hit check. Alright, now it is aligned correctly, but I do have one other problem here. You can clearly see that it is not in the correct spot on the Z. So what I'm going to do is I'm going to click on this, and I'm going to dynamically translate this. I'm going to turn my 3D mode on down here so that I have all 3 axes. And I'm just going to click anywhere. This doesn't really matter. I'm going to click the Z-axis, and I'm going to align that to 0, or the origin. Alright, so now you can see top of my part is at 0. And the next thing I can begin to do is get my machine selected. So if I go to Mill, and I'm going to pick my 5-axis. Okay, and I'm going to grab my stock, and we're going to set our stock up. So to do this stock, I know that it is going to be 1.875, and the Z is going to be 1.875, and my x-axis, if I look at my drawing here, is 3.375, so I'll probably cut that an extra 1/8 long. So we'll say that's 3.5 inches, 3.5. And I'll go ahead and hit check. And I forgot to turn it on, so we can't see it. Let me turn that on. Alright, so there's my stock. You can see it's nice and centered, or at least the part is nice and centered in the stock. One other thing that I'm going to do is I am going to move my stock. Actually, I'm going to move my part down a little bit so that I can face some material off. And I'm just deciding whether there's 2 ways I can do this. I can either move my material up and essentially face at 0. Then all of my other dimensions would be exactly what they are. And I actually think I like that better. Or I could move my part down, but then I would have to add, if the top of my stock is 0, then I would have to add to everything else. So what I'm going to do is I'm going to move my stock up. I prefer to face at 0. So I'm just going to go to stock, and I'm going to move that up, I don't know, maybe 50 thou, maybe 20 thou actually. Let's make it positive 20, because I don't want to face too much off. Yeah, 20 should be fine. That's what we'll do. So now if I look at this, there, it moved it up from the front. My stock should be slightly above the 0. So that looks good. Now, to get this right, what I would do is when I touch off my G54 off the top of my stock, I'm just going to, once I touch it off and zero it out, I'm going to put an offset of negative 20 in there. And then all my tools will be touched off 20 thousandths below the stock, right where my 0 is in MasterCAM. Your 0 in MasterCAM and your 0 at the machine have to be the same. So this is G54 right here, or whatever work offset I decide to use. That has to be in the same spot in the machine as it is in MasterCAM. Okay, so starting out, I'm going to work on the top plane. So I'm going to hit equals, and we're going to go to the top, and we're going to take a face pass here. So I'm not going to select anything because I want it to face the stock. I'm going to select a tool. Actually, before I do that, I want to turn something off. I'm going to go into Files, Tool Settings, and I'm going to turn off Assign Tool Numbers Sequentially. This is something that I traditionally have on because if I'm working in a VF2 or one of the other mills where we don't have tool assemblies for, at least not dedicated tool assemblies in MasterCAM, I do generally want it to number my tools 1 through, whatever. But for this, I have set tools in my machine that stay in there pretty much all the time. So I want it to assign those exact numbers. So I'm turning that off. This material doesn't matter. My tools are set. It's set up so that it pulls my tool data right here from tool. So this material means nothing, essentially, for me because I have it set from tool. Okay, so once this regens, there we go. So I'm going to pick face, and I'm not going to pick anything because I want to face the stock. Plus, I know that my cutter is 2.5 inches wide, so I'm going to be able to face this in one pass. All right, so select tool from library. I have to pull these over constantly because I have multiple screens. And I'm going to pick my VF4SS tool crib. And I'm also going to open up my assemblies and turn my filter off because I don't have very many in there. And as you can see, I don't actually have my 2-inch mill in here. I know where I do have one though. Haas toolbox, and I believe, nope, I don't have it in there either. Okay, so I'm going to have to set one up. So if I go to, I'll go back to my other path, and I check, and I'm just going to create a tool, and we're going to pick a face mill. Okay. So I know that my face mill is a Haas face mill. So I'm going to go to Haas tooling. I'm actually going to get some of the dimensions for this. I know the cutting diameter is 2.5. And the secondary diameter, I'm going to have to figure that one out. Let's see here. Bring this over. Okay, so we want to do milling. Shell mill bodies. And this is my type, HSNP. HSNP. I need a 2.5. That's this one. Okay, so the cutting diameter of 2.5, 3.102 is our max diameter, so that's this outside. So we can now set that for our secondary diameter. So it's 3.1? Yeah, 3.102. All right, overall length. I'm going to take a shot in the dark, 1.75 there. Okay. Cutting length, we have a 0.275. Okay. All right, and then let's see here, upper diameter. We're essentially going to make that just a little bit smaller. I don't know what that is. It doesn't actually have a dimension on our model here on the Haas website. So I'm just going to say that's 2 inches because it really doesn't matter. I'm not cutting with that, so it's not a big deal. What's really important is this diameter, this large diameter, and then the cutting diameter. That's what's the important stuff here. So I'm going to go ahead and hit finish, and that's what we're going to use. Okay, so our surface footage, I know from my speeds and feeds chart here, it looks like 800 is roughly what my surface footage is because I have unalloyed steel, and I'm going to take about 1 times the diameter, so we got about a 1-to-1 here. So it looks like 850 is roughly what we should be moving, and at about 10 thousandths, we're going to be taking a finish cut, so we'll make it 8 thousandths chip per tooth. So we'll make this 850, and we'll make this 0.008. All right, plunge rates. Let's make that 40 because we're going to come down off of the part, not going to come down over top of the part. Cutting parameters. Now, I'm not going to pay attention much to my holder here because my holder is really not that relevant. Basically, because my holder diameter is actually smaller than my my maximum cutter diameter. And I don't foresee any issues where I'm going to have any problems. I'm only going to be doing 3+2, and I'm not using this cutter on any other sides. I'm not doing any 5-axis linking. So I'm not going to have to worry about my cutter colliding really here, or my holder colliding. So I'm not going to set that up. I'm going to leave that as it is. Let's see here. Okay, so we're going to do a one-way pass. Oh, check that. One pass, I mean. And entry approach 50%. That looks good. Depth cuts, we're not going to take depth cuts because we're only taking 20 thou off. Depth is going to be at 0. Top of stock is 20 thousandths above. Feed plane, all this stuff looks good. Planes are on top. I'm going to make a manual work offset here because with these posts, these 5-axis posts, it will progressively, every operation will, or I should say, every new plane that you create toolpaths on will create a new fixture offset. So this one would be 54, the next one would be 55. You can override that here by selecting manual and making this a 0. It'll use 54. If I wanted to use 55 for all of them, I would make this a 1, and then so on. 56 would be 2. So you want to make sure that you manually override all these work offsets to the same value. That's pretty important. And it's going to ask you here if you want to update that for all operations on that plane. And the answer is yes, I do. Flood coolant is on, that's good. And it should have created a path for us, and it did. You can see there, if I actually turn off my axes, you can see our toolpath. All right. So that looks good. That's facing our part. Next thing we're going to do is we're going to want to mill around this part. Now it's 1.5 inches deep. I know that I have 1.5 inches length of cut end mills, so that's what we're going to use to cut around this part. Alrighty, let's go to toolpaths, and we're going to go to actually, check that, not contour. Nope. We're going to go to dynamic, and we're going to dynamically mill this. Machining regions, we want to mill our stock away, so we're not going to select a region because it's just going to select the stock as the region in that case. We're going to start from the outside because we're not doing a pocket, we're doing a boss. And the avoidance region, well, that's going to be my part. So this is an interesting problem here. So now I need to essentially create an avoidance region all around this part. So let's say I create multiple regions here, and let's give that a shot and see what we get. Check. So I selected all the sides. I'm going to pull a tool from the library. In this case, I want my 1/2 inch end mill steel. I do need to edit this because I know that this tool is only 1.25 inches length of cut, and I want it to be 1.5 inches. Shoulder length, inch 0.5, we'll make this 625. Okay, that looks good. Finish. I'm going to adjust the... Okay, so that's actually fine. It's already sticking out enough. So we're good there. It'll actually probably be sticking out further in real life. As long as we're sticking out at least that much, we should be fine. The importance of having this holder is to make sure there's no collisions. I'm only going down 1.5 inches, so I shouldn't have any of the collisions with this. Once we add our fixture later, that's where you'll kind of see this come into play, this tool holder. Okay, step over distance. We're only going to step over about 20%. Since we're taking such a deep cut, I don't want to step over too much. Keep that tool down within. Essentially what this is doing is making sure that it's keeping the tool down, and it's going to use a fast feed rate to return to the next cut location, unless it exceeds 100% tool diameter. So in this case, it would be 1/2 inch. I want to increase that. I'm going to make it 2.5 inches by saying 500% of tool diameter. The back feed rate, we're going to make that 800. Oh, okay, I'm limited here. I'm limited to 500. I have to change that in my machine definition, but we'll forgo that for now. 0.01. I'm going to leave some material on the walls so that we can do a finish pass. And when avoiding a boundary or exceeding a distance. So this essentially is just this motion. It's going to come up and wrap it over when it exceeds 500% of the cutter, the distance that it has to travel, or if it's avoiding a boundary. So that's what I'm setting there. Corner pre-treatment, I'm not going to use that. We don't need that for us. I'm only taking 100,000ths passes, so it should be fine taking those corners. We're going to plunge because we are coming down off of the part into air. And our depth, we know that that is -1.5, and I'm actually going to take that 30 thou deeper. I actually have a little extra on my end mill. I know that I do, so I'm okay going an extra 30 thou there. Top of stock is 0, feed plane 1, we're good. 0.1, I mean, 0.25, that's all good. These arc tolerances, I would be a little bit concerned about these if I had arcs, or I shouldn't say arc tolerance, but my tolerance, my total tolerances. If I had arcs or something like that, I would be concerned. These are straight lines, so I'm not worried about it. Making sure all this is good, and my coolant should be on. And hit check. Okay, so you can see here, it's coming down, it's milling, and you can see my rapid moves so that it repositions itself rather than rapids or fast feed rates all the way around the part. So that's this is actually a really good example of where you want it to have that exceeding a boundary or a distance. Okay. So that looks pretty good. Next, I am going to do a contour. All right, so this contour, even though the dynamic mill worked, the contour is going to be problematic. So generally, it does not like when you pick faces like this, and we'll see how this goes. So, I don't think I set these properly. My speed for that end mill is 60 or 600 surface footage and 3 thou. I'm going to slow this down for this finish pass to 30 inches a minute. And my plunge rate, I'll make that 40 inches a minute, and rapid retract. Where is on, you can see it's a contour 3D is the type. So what it's going to try and do, it's going to try and do this right here. Anywhere there is a gap down there, I want to switch that to 2D, and let's see what happens here. It's not going to like it. Stock to leave on the walls, nothing. Maximum depth variance is fine. Oh, we do want to round the corners, so external corner breaks. Let's put, actually, let's check our... So it says edges must be broken with small radius or small chamfer. It's not really defining a chamfer. So since it doesn't define a chamfer, I'm basically going to say that's about 20 thousandths, small radius or small chamfer. It's really leaving that open to interpretation for us. So external, 0.02. Depth cuts, no. Lead in, that looks good. Multi-passes, I am going to turn multi-passes on. I'm going to turn rough off. Have one finished pass at 0.01. And I'm going to add a spring pass to make sure that it's picking up any deflected or any deflection. It mills off any extra material that was left on from deflection. And that looks good. Linking is negative 1.53. Top of stock is 0 in this case because we've already milled it off. And coolant is good. Okay. Okay. So probably shouldn't have went through all those parameters, but so I knew that wasn't going to happen because it doesn't know. I just picked a bunch of faces. So I knew that wasn't going to work. So the best thing you can do is we can actually leave this and we can reselect a chain here. And what I'm going to do to reselect that chain, the easiest way to get this is probably just to create a level. And I always create levels for, and I'm going to say top geo, so it's my top geometry. And essentially I'm just going to draw a rectangle from here to here. And hit check. Oh, it drew at the bottom. Shucks. All right, let's undo that. So sometimes I can't see where I'm snapping to. So it snapped to the top or to the bottom rather than the top like I wanted. So to prevent that from happening, what you can do is just turn on your 2D setting, and now it will always draw geometry on 0, basically at your Z0. So let me pick rectangle. Do that again. Check. And now you can see I have my rectangle here. Okay, so I'll go back into my geometry, and I'm just going to do rechain all. I'm going to come out of my 3D solids, and I'm going to pick my curves. I want to make sure that I have the arrow pointing in a way that is consistent with climb milling. In this case, it is not, so I want to reverse that arrow. And I'm going to go ahead and hit check. And I'm going to go in and make sure that I have it off to the left, my cutter comp. I do. So everything should be good there. All right, and there it has now redone our contour. Okay, so everything looks good. All right, let's verify that and see how that looks. All right, so that looks good. It is putting a small radius on there, or 20 thou that we asked for. All right, so I'm going to turn these off. And next we are going to, well, I guess we might as well mill out this slot. Now, you might be wondering, okay, well, can we drill and tap these holes first? Well, the answer is yes, we can. But what I'm thinking here is when I go and I remove this material, I'm worried that this is going to move a little bit, which will change the location of my holes if they're drilled prior to that. This isn't a huge concern of mine. The outside is not a critical dimension whatsoever at all. It's plus or minus 5 thou, and it could be plus or minus 20 thou. Not a critical dimension. That is one of the advantages of actually engineering the part or creating the part yourself. You can control what is important, and you know what is important and what is not. What is important is the dimension between here So we are going to peel mill this out. And these hole dimensions are actually pretty critical too. But the outside dimension, not critical. So if that thing does spring in a little bit, I don't care about the outside dimension. I'm worried about the dimension of that channel, and I'm also worried about the hole dimensions from hole to hole. So I'm going to wait until I mill the channel out to drill those holes so that they are actually on location. That way, if this material relieves itself a little bit, the holes don't move in with it. They'll be drilled in position. If I did care about the outside, I would actually probably mill and leave maybe 10, 15 thou, maybe even 20 thou on the outside, and I would do my finish pass for that after I took most of the material out of the channel. That way it would relieve itself, and I could, again, make sure that that part was getting milled square. But it doesn't matter in this case, so I'm not going to worry about that. I'm actually thinking about it, and I'm going to say, well, you know what, let's do it that way. It ain't going to hurt anything. It's not going to cost us any more time. So I am actually going to insert my peel mill before I do that finished contour around the outside. Okay, so toolpaths, let's pick our peel mill here. And again, I may have some issues. Actually, I won't. I could pick these lines here. So basically, I just need a straight line all the way down the part to pick for this peel mill. So if I select that line, end, and that line. Check. Tool. I'm obviously using the same tool. Again, this is going to be 600 inches a minute. And I do usually have these tools set up for the correct speed, but I'm actually using a different brand tool. I probably should create a new one so that I have it in there. 3000 fine, plunge rate at 40 inches a minute because I'm not coming down into the material. Let's see here. Step over distance, we're going to do 20% again. Climb milling. Toolpath radius is important for this. 500 back feed rates fine. No material left on the walls. Additional entry and exit. Don't need that. I think everything in there is good. We don't want any depth cuts. We do want some finish passes here. So I'm going to leave 10 on. And then I'm also going to take a spring pass at the end. And I'm going to override the feed rate for that too to 30 inches a minute. And that should be pretty good. We have our wear on so that we can adjust it if need be. Linking parameters, we're going to make our depth correct. Top of stock is going to be right there. And everything else there looks good. Coolant's on. Okay. All right, so there is our peel mill. One thing I can see here is that it's starting, notice it's starting our finish pass right on the edge. So we want to change that a little bit. I'm not real wild about that. We need to put a lead in and lead out on there. And let's reach in that. All right, so that's a little crazy to lead in and lead out there. So let's get back. I didn't actually look at that. 10, 10. All right, let's see what that looks like. Let's preview it. I'm going to use this little button right here to preview what it looks like. Okay, so notice it's leading in. Problem there is that it's still starting right now. I actually want to extend that a little bit. So what I'm going to do is adjust contour, and I'm going to extend it maybe 0.1. Check. And now you can see that I'm actually it's starting out a straight line a little bit before. Now, the one thing it doesn't do is it doesn't, when it shows your lead-in lines, that's part of your lead-in, so that's not going to be in blue, it's going to be in green. The key is just to making sure that, you know, there's a straight line there as opposed to just an arc that's tangent to that point. And I do want to double check that actually, because I'm not convinced that it is. Ah, it didn't save it. 0.1. That's better. Okay, there we go. Yeah, wasn't quite convinced. Now you can clearly see it, that it added that extension. All right. So we have that. I'm going to turn that off, and let's see what this looks like when we run it. Okay, everything looks pretty good there. Now we do probably want to add a small chamfer to here. So let's go back and add that in. So to do that, we're going to have to create some geometry. So let's go to top, and I think I'm still on top geometry. I am. All right. Oops. Wireframe. And the goal here is just to create geometry so that, that's interesting. That wasn't snapped correctly. All right. I've actually changed my mind here. I'm going to put this on a different one so I don't mess up my turn that one off. Okay, and I'm just going to turn that into geometry, that, and that. And then we're going to add a chamfer. So I'm just going to make it 0.02, just in keeping with the other radii that we have. All right, check. Okay, so I'm going to turn this off, and it was supposed to trim that, but for some reason it did not. Yeah, I had trim entities clicked on. Whatever, I can trim them. Ah. So this seems a bit tedious, but really the idea here is that you want to make sure this part comes off completely deburred. No reason to spend time deburring something, especially when you're doing it in the 5-axis. It should come off complete, so you don't have to touch it. Okay, so where am I going here? I lost my train of thought. Ah, yes, I already have this. So go back in. If I can slide over, there we go. Go to my peel mill. Gonna repick, rechain all. And I'm going to pick a partial. Select there. 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 And, oh. I spazzed out. Clicked the wrong thing. Okay, check. Check. Let's see if we can regen that. Hopefully that regens. No operations were selected for regen. Okay, there we go. We did regen it. That one, Alt-T. Alright, so there is our path. And now you can see our chamfer has been added there. Okay, so let's see what that looks like when we play it. Now you can see our chamfer. And there we go. Alright, so that looks pretty good. Next thing I'm going to do, I might as well stick with the chamfers. So I'm going to come back to my solid. I'm going to X out of there. And we're going to, well, we're going to go around all of these profiles on the top. And so, yeah, actually I rethought that. We're going to wait to do our chamfers, so that way we can chamfer everything at once. After rethinking about that, it doesn't make sense to do it now. Next thing I'm going to do is I'll mill these slots here out. So we'll dynamically mill those, and we're going to start from outside again. And our machining regions are going to be right there and right there. Check. And we have some air regions here. So we have air regions. If I select that end and I select that end, check. Tool. I'm not sure what that radius is in there, so I'm just going to pick a tool and then I'll come back and change it if I need to. Hopefully I can get in there with a 1/4 inch end mill. Hoping that's an 1/8 inch radius. But we'll see what happens here. So all those speeds and feeds are right because they're set up correctly. I know that that's right. Let's see, step over distance. We'll do 25 for this since we're not cutting much material. Stock to leave on walls, 10 thou's fine. All this stuff looks good. Depth cuts. Depth cuts looks good. We don't want to do anything there. Plunge only. Depth. We're going to select the bottom of that. And top of stock's going to be 0. Planes, everything else looks good. Alright, so you can see there, it comes in and mills that out. Let's see if I got my end mill right here. Analyze entity. And the radius is 70,000. Perfect. Oh no, that's actually not perfect. Shoot. So that diameter is 1, so I need to use an 1/8 inch end mill to come back in there. Alright, we can do that. So we'll come back in and we'll do a rest mill. So come back into our tool paths, we'll pick another dynamic path. And same thing, same machining region. Oops. Same machining region there. Oh, darn it. Unselect. And check. Air read. Oop, not avoidance. Escape out of there. Air regions. And okay. Alright, so we'll pull up a tool, our 1/8 inch end mill. Everything looks good there. Cut parameters. We want to do a rest material. One other operation, which is going to be this one. Yes. Okay. Everything there looks good. It's entry motion. This is 0. Check. Alright, so you can see there it's cleaning out that corner. And then what I'm going to do is I'm just going to use my contour to finish that. So I want to make sure that I'm climb milling in this case. We're going to do a partial. Check. 1/8 inch end mill. That plunge rate is way too slow. Wears on 2D. This here is all pretty good. I just want to make sure that I extend this a little bit. So extend this 0.02. Multi-passes. I'm doing a finish and a spring. That should be fine. I probably could get away without even doing a spring there. But let's leave it in there just in case. 0. And that looks good. Okay, so there we go. One thing I want to do is go back and look at my dynamic peel. I'm actually going to put a depth cut in here, a finish step of 10 thou. Mainly just because I want to hold that depth pretty accurately. I still want a nice finish on that floor. So I decided to change that. So we're going to hit check for that. Alright, so it added a finish pass at that depth. A lot of times what I'll do there, actually, is rather than use that, a lot of times what I'll do is actually create another path, and I think that's what I'm going to do. I don't want to step over 100 thou if I'm only taking 10 thou off the bottom. I want to step over a lot more than that. And I don't have that option to change my step over just for that finish pass. So since I don't have that option, I'm actually going to just create another peel mill pass there. And, you know, one of the things you may have noticed is I'm kind of indecisive when I make these videos, and that's because I'm thinking through it in process, right? I don't have this rehearsed or anything like that. I'm thinking through it in process, and I'm seeing what's happening here, and I'm seeing it, and I'm thinking, okay, well, I don't quite like that, you know? So I'm going through it, I'm changing things as I go. Which is realistic to what you'll be doing. So that's kind of why I like to do it that way. So this looks good. All my speeds and feeds are good. One thing I didn't see, that's 40, that's good. This here, the step over, we're going to make this like 75% of cutter. We're only taking 10,000th off the floor. So, you know, we're not worried about that. Finish pass. Let's see here. We do want to take a finish pass here. So that's where we're going to take our finish pass. Depth. Well, it helps if I have the level on so that I can select that. Okay, 0. And everything else there looks good. And I just got to go adjust my other one. Okay, so that looks great. Let me turn this one off. Yeah, so you can see the amount that it steps over. There's much shorter toolpath for sure. So that looks good. I do want to adjust this. I can turn off this finish path. I don't need that anymore because I'm doing it in the last one. And I also need to leave some material on the walls, 0.01, and I need to leave some on the floors, 0.01, for that next operation to take off. Okay. So I think we're good now. I think I can live with that. So let's take a look and see what we got here. That looks a little interesting. I wonder if that's just graphics. It appears to be just graphics. The way I can tell is I can see my toolpath here. My toolpath looks straight. So I don't see any issues there. That's something I'll keep an eye on when the first part comes off, though. Make a mental note of something like that didn't quite look right in graphics. So it's the first thing, one of the first things I'll look at when that first part comes off. I'll double check and see what if that looks like it's gouging in them corners or not. But I don't think it is. I think that's just a graphics issue. Okay, so let me turn all of these off so they're not in my way. All right, so we have a couple more things we can do on this face. We can drill these holes. Again, I'm going to wait till last to do that, or almost last to do that. The other thing that I can do here is I can put this little slot in. That little slot is going to be done with a woodruff cutter that I have here. It's telling me that the slot is 200 wide. This woodruff cutter is 3/16. 200 wide plus or minus 64, so it does actually fall within tolerance. The other thing is I know what this is for. I just arbitrarily drew it to 200 thousandths wide. Probably should have just drew it at 3/16. At the time I wasn't sure what cutter I had, but I figured I had something around 3/16. So I don't really care if it's wider, or if it's narrow. It doesn't really matter. It's just for grease to pass through. It's only 10 thousandths deep. Now, ideally, a woodruff cutter wouldn't be used for this. We would use a T-slot cutter because they have relief on the flutes. But it's not uncommon in industry to, use what you have. We do not have a T-slot cutter. We do have a woodruff cutter. And this will work for what we're doing here. Plus, we're not taking it real deep. We're only taking 10 thou, so I'm not really worried about chips binding up. So this will work just fine. Okay, so to do this, you might be thinking, oh, well, how in the world are you going to program that? Well, let's take a look. So first thing is, what toolpath am I going to use? Well, essentially, I'm just going in a straight line. So I'm going to use a contour. So I'm going to pick contour. And I'm going to select a single. Well, actually, I'm going to go into my solids and select a single edge. And I'm going to select this edge. And I do want to think about this, and that actually is the wrong direction. So I want to reverse that. And I'm going to hit end. Okay, so right here I can already see I have a problem because that hole intersects it. I can't pick that whole line. Alright, so that's out. I'm going to pick no there. Other things I can do. I can draw a line there, which is probably what I'll end up doing. But I could also use this top line as well and just add to my depth. Right? It doesn't really matter what line it is. That's just that's the path. It doesn't necessarily define my depth. So that's actually what I'm going to do. Spin this thing around. And I'm going to select this line that is at the correct location. And note that goes the whole way through. And going to select that line. Enter. Alright, now we know we don't have a tool like this. Well, at least I know we don't have a tool like this. So I am going to create one. So I'm going to create a tool. It's going to ask me what kind. As I go through here, here's a slot mill. That's going to work perfectly. I'm going to hit next. Grab my calipers out of the drawer here. And I'm going to measure this diameter of this cutter. It looks like I'm getting about 8.845. So 0.845 will be our diameter. Our overall length, sure, we'll try and get it as accurate as we can, I guess. 2.2. Thickness, that I know is 0.1875. And upper and lower corners, they are square on this part. Shank diameter. Oh. Helps if I put the right thickness in. Shank diameter is indeed, I believe, 1/2 inch. It is. Okay, so that all looks good. Shoulder length, there really is no shoulder length here. Obviously, you can tell that there's a little inset because it is a woodruff cutter. It's generally what tells you the depth of how deep to plunge the woodruff cutter in. Doesn't matter. As long as I have my maximum diameter here, I'm not going to exceed that anyway, so I know I'm in good shape. I'm not really worried about the shoulder length either. It's pretty much pointless. I'm going to make it 0.2 just because it bothers me seeing that different color there. Finish. Okay, so we got our slotting mill, and I'm going to create a holder for this. So I'm going to go to Open Library, and I'm going to go to my CAT 40-inch, CT 40-inch, open that up. And these numbers, these 0, 20, that is your collet size. So ER32, or sorry, ER20, ER25, 32. So that looks just like one of our ER32 holders. I believe that's what I'm going to be using. Yeah, I think I'm going to use that. So tool projection, we'll say this thing's going to be sticking out maybe 1 inch. That should be fine. If I need to move it up, I'll move it up, or move it down, I mean. Everything looks good there. We're going to put wear on. Compensation's off to the left. That's good because we're climb milling. Brake external doesn't mean anything here. We don't have any external corners. We do have a lead-in extension. That is just fine. Breakthrough multi-passes. I am not even going to leave multi-passes on here. I'm going to do one pass. I don't care about the surface finish in this thing. It's not functional other than just to leave space for grease to access the back of it. Depth. The depth of this is going to be at that location. 0 is my top of stock. And planes, colons on. Check. Okay. So if I hit Alt-T, I should... Oh, yeah, there they are. So you can just barely see them over this, but that right there is my path. All right, so let's go ahead. One thing I did notice. Oh, so we're gonna have a problem here. One thing I just noticed when I was looking at this is that the start for this side is past the other side, which means that my cutter is wider than my slot, which I didn't notice originally. So that means I'm not going to be able to use this cutter. I'm going to have to find a different cutter. That's kind of upsetting. So what I'm going to do for now, I'm going to go in and edit that tool, and I'm going to make it as 0.625. And I'm going to make the shank of the tool 0.375. Hopefully I have a cutter I can find. I'm going to use this as a placeholder for now just to continue programming. Okay, so now you can see that looks a little better there. Oops, regenerate. That wasn't the one I was looking at. Okay, there, that looks a little better. Alright, so let's see what it looks like when we play it. See if we get our groove. There we are. So we have our slate groove in there, and that looks good. Okay, and by the way, any kind of see like a wave right there along that line. That's just graphics again. I'm not sure why it does that, but it always does that on chamfers. All right, so let's X out of there. All that stuff looks good. Turn all those tool paths off. Okay, so we have essentially all our milling done from this perspective. The only thing that we do need to drill yet is this. It's the last hole that I'm going to drill from there, or the last, well, I guess it's not the last hole because I got to do these two. It's the last thing that I could potentially mill, but I'm not going to mill. I think I'm going to drill and ream that. So we'll keep moving along here. All right, so the next thing I'm going to do is I think I am going to do that hole next, because these other holes, I'm fairly certain if I bring my print up that they match. So these are 1032s and these end winds are 1032s. So I can do all those at once and have it reorient the part once I pull those tools up. So I'm going to do everything I can in this view complete, and then we'll switch views. All right, so let's drill those holes. So, or drill this hole, I should say. So we're going to pick drill, select that hole, check. And I am not sure what size that is. I have to take a look. It is a 374. Okay, so let's go grab a drill from our library here. And I don't have anything that really works too well. That's really pushing it to run a reamer through, so I need something closer than that. Ideally, I want something that's about a 64th under. It's close to 3/8, so 64th, maybe a little extra would be okay. But essentially, I want to stay around a 64th. So I'm going to come down to my steel inch, and that's going to give me a crazy amount of drills as soon as I get off assemblies. Okay, so there's our 375. Right here is our 2364. So that's what we're going to use. So I'm going to select that 2364, drill that at 5 inches a minute. Speed's right. Holder, let's open up our library here. And again, I'm picking this holder because I don't want collisions. Anytime I do something in the 5-axis, even though I probably would be fine because I'm only using this for that hole that's going to essentially be a 3-axis move. I'm basically milling it like a normal 3-axis part. But just abundance of caution, I like to make sure that it's... So I'm actually going to edit this tool. Edit tool. Overall length is 3 inches. Cutting length is, let's say 1.5. I'm going to say this is 2. And we're going to say this thing's sticking out. I don't even want to say that much. I'm going to say 1.65. And that looks pretty good. So I'm going to hit finish. And I'm going to have this 1.75. And we are just going to drill this. We're not going to peck drill or anything like that because we're not going that deep. So I'm going to come down. My depth. Zero. And I want tip comp on. Breakthrough amount extra 10. Make that 0.05. Preview that toolpath. Okay, so when you look at this, you can see it's drilling down through. That's good. But if you take a look where it's starting, I don't want to drill a bunch of air. So what I can do to fix that is I can go top of stock and I can choose the hole. And I can also go retract and I can choose the hole as well. And I can just reduce this. Maybe I'll make that negative 0.5 and hit check. Alt-T. One of my big gripes is that sometimes this Alt-T doesn't work as well as I'd like it to. The other thing I noticed is that I'm way too deep on my... I don't know where I got 1.5 at, but I can adjust that. So I'm not seeing... There we go. All right, so now it's going to start drilling right there. So wrap it down to there and then drill. All right, so that looks good. Let me adjust these contours. I got the 1.5 from the wrong dimension. So I want to adjust this. Linking parameters, negative 1 point. In this case, we'll make it 2 because 1.125. Check, and that finish contour, which is right here. Negative 1.2. All right, so we've got our drill, and I'm using a split point drill, so I'm not going to spot drill that. Next, I'm going to drill this again, and I'm essentially going to do the same thing, only I'm going to use a reamer this time. So I'm going to select and filter. I'm going to pick a reamer, check, and we're going to just pick 3/8 reamer. In reality, it's not going to be a 3/8 reamer. 0.374 reamer. Finish. And the only reason I changed that name is just so I can see that when I print out my tool list. I don't accidentally, even though I should know, it's very easy to make that mistake when you're in the moment and you just grab a tool. So open library, CT40, and we're going to use our 32. It's definitely going to be sticking out at least 3 inches, but that'll be fine. I'm just going to leave it at that because I'm not worried about that one hitting. Tool, we're going to run this at 35 surface feet, and the feed rate we're going to run at about 12 inches a minute. Okay, so there we go. Remember, half the speed, double the feed. That looks good. That's for a reamer, obviously. This is negative 0.66. Depth, bottom of that hole. Tip comp is on with 50 thousandths of breakthrough. That looks good. Okay, so there we go. Actually, I want to take 0.025 breakthrough. Actually, I'll make it 30. I don't want to hit the bottom of that hole. So I'll hit check. There we go. Ah. Picked the wrong one. Depth. There. Check. There we go. Okay, so that looks pretty good. All right, next thing I'm going to do is the holes. So I'm going to grab those holes. So we'll just start here, and these are getting tapped. So I'm going to select. So there is a way that I can drill all of these holes all at once, even the ones on the side. I don't like it. Sometimes it works, sometimes it's very finicky. So to use that multi-axis drill path, not a big fan. So I'm going to go ahead and hit check, and I'm just going to create these on different planes, and then I'm going to use my multi-axis linking to link all of those tool paths. That tends to be a little bit more robust and create a better result than what you normally would get with the 5-axis drill. Tool. Okay, so these are 1032s. So if I'm not mistaken, I believe that is a number 25 drill. Those drills, number 25. This is assuming that I'm using a cutting tap and I'm not using a thread forming tap, obviously. If I'm using a thread forming tap, it would be a bit different. Okay, that looks good. And you'll note that I'm not worried about these tool numbers right now. I'll go change those later. Not a big concern. It's just getting the ones right that I know that are in there. I'll change all of the new tools that I've created. Okay, so this length is definitely a problem. Definitely got to change that up. Overall length of this is going to be about 2.5 inches, maybe. It might only be even 2. Cutting length, we're going to say it's 1.0, and we're going to say 1.5 is the shoulder length. And then finish. And actually, that's too much as well. I changed my mind on that. Finish. All right. And open library. For this one, I'm going to use CT40, but I'm going to use a 16 here. So I'm going to use one of my smaller collet holders. And actually, the other thing I'm going to do is use an extended one. So I'm going to use an extended holder. Drilling this, these aren't particularly deep holes. Even though they show it here, we're not going to go that deep. It's not necessary. Okay, so the depth, we're going to go negative 0.625. And that's from 0. This is going to be 0.25. Tip comp. Everything looks good there. Coolant's on. Check. All right, so let's drill all those holes. In fact, actually, it's going deeper. I take that back. So they don't go deep at all. Man. All right, let's change that up. Let's go back into linking parameters and make this negative 0.375. And it's about where we want to be. All right. Okay, so I started here, I finished here. Since I'm finished here, I am actually going to go and drill this other side. Now, this is where we get into the 5-axis part. So up until now, pretty much should have known how to do all this stuff. So what I need to do now is I need to create a plane for this. And I always create my own custom planes, dynamic, and I can really put this anywhere I want on here. I just have to make sure it's oriented correctly. So to orient this, I'm first going to select here, -90, and here, in this case, it's going to be 90. Okay, so basically I'm going to be looking at my part like this, and that looks good to me. And this is the right face. And generally I do these all in caps. That way I can pick them out really easy when I'm looking at this. I can just see the capitals really quick. Okay, so right face. When I program something for 5-axis, the WCS is always on top. So WCS is always set to top. Depending on what face I'm working on, in this case, well, before I had my construction and my tool plane on top because I was working on the top plane. I was creating tool paths on the top plane. I'm now going to set those to the right face. Okay, so now it's creating all my tool paths on this plane, but it's referencing my 0, 0 from the top plane. So basically what you need to know is anytime you switch planes or a different face, you're going to leave WCS set to top, and you're going to change your construction tool plane to right face. And if I want to actually see this plane, I can use this G view, my graphics view, and I can click it in there and it'll put me on the top of that. I don't want that right now though. So I'm going to select these holes. Check. Tool. Same tool. Everything there looks good. Holders, of course, the same. Everything should be pretty much exactly the same. Except for the depth, -0.375. Tip comp is on. Let's see how these are set to right face. Now, my work offset's different because I'm working on a different plane. I'm going to set that, manually override it to 0, and hit check. It's going to ask me if I want to do that with all of them. Yes, I do, even though there's only going to be 2. And I'm going to hit check. Okay, so now I've created the tool path on that plane. Next is the other plane, the left side plane. Is that right? Oh. Hold on a second here. I think I accidentally named the planes wrong. I did. That was my left face. Okay. Edit. Check. All right. New plane. Oops. Dynamic. Okay. Grab that. 90 degrees. Grab this one. -90. Okay. And that's set correctly. This is going to be right face. Check. Construction tool on that plane. Create my drill. Check it. Tool paths. Looks good. Everything in here should be good. Should be the same. -0.375. That should be good. Top of stock is going to be 0, and retrack is 0.25 absolute. Check. Okay. One thing I did want to check was where I had my top of stock on that last one. Yeah, that's 0. Check. It does sense where my stock's at, but remember, my stock's not there anymore, so there's not a 1/16 of stock there anymore. Okay, so that looks good. All right, now the next thing I want to do here, I'm going to get rid of this, and close these up. These are the three I just created, so these are the three planes. I'm going to select all of those, and I'm going to select, well, before I do that, I'm going to bring in my fixture. So first I'm going to save this thing so I don't lose anything if something were to happen. Bar puller housing, perfect. Save, file, open, computer, browse. Fixtures, Raptor Vice. So right there is exactly why, because I screwed up and I didn't do it right. What's that? Bar puller. Open that housing again. Okay, file, merge, which is what I should have picked the first time. Drawings, fixtures, Raptor Vice. Okay, we're going to add our vice here. Alright, so I'm going to go from the right side, and we're going to dynamically move this vice. And when I move this vice, I just move it close. I don't really care if it's perfect or not. So that's really essentially where we're going to be gripping it. I'm going to hit check, check. And then I'm going to select these jaws here. And I'm going to go back to that right side view. And I'm going to dynamically move those. Just till that reaches the stock, because that's essentially where it's going to be. And I'm going to hit check. Oh, undo. I almost forgot. I want them to be consistent. Dynamic, front, oh shoot, right. Alright, so there, I generally look at where it's at. So 0.275 is what I'm going to use, 0.275. Check, and then I'm going to select these, and do the same thing, only I'm going to move these negative 0.275. Negative 0.275. Okay, so now I'm holding on to my stock with my fixture. Alright, the next thing I'm going to do when I simulate this, I want it to show that. I know that when I brought that in, that's going to be on level 21. I brought a bunch of other goofy levels in too. Usually I just go in here and I go clear empty levels all. And now I have a fixture and the levels that I created. Okay, so if I want that to show up, I'm going to go into my settings. And stock is going to be from stock setup. My fixture is going to be from 21. And I'm going to hit check. Now, when I go to my verify, it's going to show my fixture. And now I can see whether I have a collision with my tool holder or anything like that. And I'm nowhere close in this part. So no big deal there. All right. So the next thing I'm going to do is I'm going to do a multi-axis linking. What's going to happen right now is it's going to drill those holes in the top, and then it's going to retract all the way up to Z0, rotate, come back down, drill the 2 on the one side, retract all the way up, rotate, drill the 2 on the other side. I want it to just stay close to the part. So what I'm going to do is go to multi-axis linking. I had those 3 selected. You can see here these are all selected, so I don't want all of these. Apparently I had them all selected. I only want these 3 drilling paths. And I need to create Linked operations must have the same work offset. Oh, okay. I didn't change my work offset for one of these. Didn't override it. There it is. 0. Okay, let's try that again. Now that they have the same work offset. Safety zone. Okay, so I'm going to use a feed rate, 500. Define this shape. So I'm going to select this. Basically, I'm going to select all my solids on here. Hit in selection. And this is going to create a safety zone for me. Now, I don't need all this in the safety zone. So I'm going to pick wrap. And it's going to do this. And then I'm going to tell it minimum volume. And I'm going to put an additional offset. So basically, it's the minimum volume that you could fit everything in here. But I'm going to add maybe 0.1 to that. And it's not updating, but it will. Okay, so there it updated. So now you can see everything's 0.1. It's 0.1 bigger than the minimum volume. So I'm going to hit check. Okay, so now you can see my path looks like this. So it's drilling all these, coming over here, drilling this one, and then it's creating a feed move that comes over to here rather than going up and all the way back down again. This is a fast feed rate, so it's going to move at 500 inches a minute, which really can be 800 inches a minute, and it will be when we're finished with this. And these levels will automatically be ghosted, or these operations will automatically be ghosted, and this is the operation that you would view. So this operation here has everything in it now, and those are just ghosted. Okay, so that is done. I believe we finished with this side. So we're going to start with that side when we go to tap it again. So I'm going to go ahead and pick drill again. I'm going to pick, should be previous, yep. Check, tool, from library, and we're going to pick our taps. Check it, tools, looks good. We want 1032, check. All right, spindle speed. All right, so I'm going to base on the feed rate. So I'm going to go 25 inches a minute, and it's going to give me an 800 RPM speed feed rate. So that should be fine. Holder, open library. We're going to do cat 40 inch, and I'm going to do one of them extended 16s again. That is way too much stick out for a tap, obviously. So I need to go in there and take a look at that tap size. Cutting length definitely is not 2 inches. We'll say that that might be 0.75. Shank diameter, I don't care about that. Overall length, we can say it's about 2 inches. And shoulder length, we'll say that's 0.8. And finish that. And we'll put this up in the holder. By the way, the reason I change the tools is because the tool projection won't allow me to go any less than what the, I believe it's the shoulder diameter. So if my shoulder length is 2 inches, I have to have the tool projection at least 2 inches or more. So that's why I'm going in and changing that. So we'll make this 1.0. There we go. It's more realistic. Okay, I've changed my operation to tap. I do not want to peck tap. So we're just going to make this 1 inches. That way it's deeper than what my depth is going to be, so I don't have to worry about it trying to peck or anything like that. Depth, we'll make this negative 0.375. And top of stock is going to be 0. 1/4 inch retract. I could tighten these retracts up. They're actually pretty high above the part. I'm going to turn my tip comp off for this. Now I know I'm going to go exactly to 0.375. That's where the point's going to go to. The diameter of the drill went to negative 0.375. So I know I'm going to have clearance there. The one thing you have to be careful with is pushing chips down in there. So you want to save some room if you're using a cutting tap. The good news is we're not going to use cutting taps. We're going to be using forming taps, so you do not have to worry about that. I do realize that I picked a cutting tap drill diameter. You know, we obviously would have to change that, but for this, I didn't want to walk through calculating it for this this video. So tip comes off, manual. I think these are supposed to be left, actually. Left face. Wait, is that right? No, right face was it. Check. And oh yeah, there we go. We're already on manual. Okay, there we go. So we're good. Check. All right, they look good. Now coming back, I might as well go and do my top holes because that's the more efficient way to make my way back. The only reason I did the top first last time because I was already on top. So it didn't make sense to orient, reorient, reorient. I only oriented 2 times last time. Okay, so let's go to, well, let's change our plane. So let's make sure we're on our top plane. Obviously, you can change that in the toolpath if you forget to change it. I do it all the time. It's kind of frustrating, but... So again, selection is important. I want to select the actual wall of the part, not the center. There we go. Okay, and then check. Something you may notice there is I did not do that the most efficient way. So let me go back and just do that more efficiently so that you can see what I do here. So I'm going to start here, go here, here, here. And I could have tried to sort these if I wanted to. Which this sorting will allow you to do that kind of thing. Selected, I can do this, where it does that. Basically, I can do anything I really want here. So if I did that, it's basically going to do the same exact thing that I had. So that looks good. That way I've worked my way over to this edge. Now when it rotates, it'll already be pretty close to there. And we're going to do the tap again. Everything's set correctly there. The holder's good. Cut parameters are good. Anything that should be off here is this stuff. And we're going to go negative 0.375. And that all looks pretty good. Tip comp. Check. Alright, so those look good. And the last one, we're going to do left side face. Drill. Check it. 0. Depth, negative 0.375. Check it. Okay. All right. So they all look good. The last thing I'm going to do, or one of the last things I'm going to do, select all of these. If I can get them to select. Come on. And we're going to do a multi-axis linking again. That looks good. Define my shape. Again, selecting everything. Got my additional offset on there. Check. Check. And you can see there it created my path to do these. And that is extremely efficient. Okay. All right, so we finished up on this face. The last thing we have to do is we have to chamfer everything. We have to go over everything with a chamfer mill, which is extremely exciting. So let's go ahead and do that. Let me see. I'm going to create chamfer. I'm going to work on that plane there then when I get a chance. All right, so the last plane I ended up on, I believe, was my left side face, if I'm not mistaken. Yeah, left face was the last drill that I did. So that's this face. right here. So that's where I'm going to start chamfering at. So I'm going to chamfer this hole and this hole with a chamfer mill. I'm using a 1/4 inch chamfer mill, so really I can just drill these, which is the easiest way to do it. So I'm just going to go with a drill, select these again, check. I think that's it. Enter, escape. Oh, there we go. Not sure what happened there. I think I might have threw a menu somewhere and I didn't see it. Okay, so we're going to pick our chamfer mill, and I do have an assembly for this in my tools. Filter active, chamfer mill right there, 1/4 inch. Feed rate 30 inches a minute. Surface footage is 500. That's good. 30 inches is a little fast to be drilling these at, so we're just going to change that to a 15. Holder's all good, and we're just going to do a drill, and I'm going to add a 0.5 dwell there. Okay, so if we go to 0, we really want to select the diameter that we're going to here. So top of stock is going to be at 0. We'll make this at like 0.05. Actually, make it 0.1. Our depth is going to be important here. So if I calculate this finished diameter, think about the outside diameter of a 1032 tap. It should be 187, or basically 190. We want a little bit chamfer past that. So let's say we want to go to 200. So we'll go to 0.2. Oops, not 0.5. That ain't gonna work. Tool tip on flat, 20 thousandths, and I'm going to add this to the depth. Check, and that should be the right depth to give me what I need. Give or take a little bit. So we may have to adjust that, but that should be pretty darn close. The more accurate we know what that tool tip is, the more accurate this is going to be. That's really the only variable there. But I think our tool tip's usually around 20 thou. Okay, so that should be good. We don't need tip comp because we just created the correct depth. Planes, left side face, all that looks good. Coolant is on. All right, so there's that. Next up, I'm going to do the same thing with all of these holes, and we're going to do some other stuff up here as well when we chamfer. So I'm just going to start out by doing that because we already have our holes correctly, or our parameters for the holes in there correct. All that stuff looks good. Just double checking some stuff here. Linking. Okay, so obviously that depth isn't good. Well, that's because we're on the wrong plane. Linking. 0, 0.1 looks good there. And again, I'm going to calculate that. Check. All right, and we should be good there. Okay, so we've got that. The other thing we need to do here is I'm going to try and decide whether I want to try and chamfer that or not. I really don't even want to try and chamfer this. There's really just no need to chamfer that. You can pretty much, it's going to be covered up anyway, and I don't think it's going to throw that big of a burr where it's really going to matter. So we're just going to chamfer around the outside. We're going to chamfer the bottoms of these. All right, so first thing I'm going to do is I need to create, first I need to get on the right plane because I wasn't. Go to top, I'm in 2D, and I'm going to go to my level where my chamfer, yeah, okay, good. Wireframe, I'm going to create myself a, it's very difficult to create this one. You have all this stuff. so that looks good. Check it. Turn this off. All right, so there's my chamfers, or where I'm going to put my chamfers anyway. Tool paths, contour. Just thinking about which way to go here. Oops, unselect. Chain. Check. Tool. Again, we're going to be using a chamfer mill. This is actually correct now. I got 40.0. Where off to the left, 2D. We want to make it a 2D chamfer. Chamfer width 0.01. Oops, 1. I realized that that's smaller than the radii. They were outside radii. This is just deburring it, so I'm just putting a 10 thou chamfer on there. Bottom offset 0.02. Depth cuts, that looks fine. No depth cuts, no adjusting the contour. Linking parameters, that's going to be at 0. Top of stocks at 0. All that looks good. Top, coolant's on, hopefully. Yep. Okay, and there are our chamfers. Alright, so they look good. Okay, we're going to get rid of that. Turn on our puller housing, and the last thing we need to do on this face is we need to do a chamfer on here. Now I could have did that on the other face, but it might as well just do it all on this face. So I'm going to pick a contour again, and I need this one here, and check. All right, tools correct again. 2D chamfer, this time we're going to use a top offset of 0.002, and chamfer still 10 thou, off to the left, depth cuts no, lead in, lead out. We are going to turn our lead in, lead out off, we're going to adjust our contour, we're going to shorten this thing. Generally I found about 25% usually is pretty good. We will check that here in a minute. Negative 625 is right. 0. And this is negative 625 because remember our 0 is the top of the part and our geometry is right here. I could make this 0 and select incremental as well. Either one of those is the same. They're basically the same thing. They are the same thing. Not basically. They are. Okay. Okay, so that looks pretty good. Let's just run that quick in backplot so that I can step forward and see where my tool ends up and if it is colliding. That does not look like it's colliding. So I think we're good there. All right, so that's acceptable. Everything is done on there. The only thing I could do is I could add a chamfer to this, but I just don't see a need to do it. If it was pushing up a burr after I run the first part, I might go back and add it. But again, it's being covered up by a plate, so there's not really much of a need to do that. Okay, so next I am going to do the last side, which is going to be my right side here, I believe. Yep, my right side. So go to my planes, come to my right face, select it, go to my toolpath, and of course we're going to drill these again. Check that. Tool, chamfer mill still. So I already got my stuff in there. And that's good. Everything looks good here. 0. That's 0. This check. Negative 90. That looks good. Planes, right face, coolant. Okay. All is well. Alright, so I think we've got everything there. I think everything is chamfered. I don't know. We'll double check here and see what happens. First, I'm going to select these. I'm going to do a multi-axis linking. Safety zone, define shape. Grab everything. Check it. Check it. So when I do a multi-axis linking, you've probably noticed that I do it by tool. So I don't have multiple tools for one multi-axis linking path. Basically, if I'm using that chamfer mill, I put all my chamfer mill operations under one multi-axis, and I create it per tool. Not you can create it for multiple tools, but it doesn't. It's kind of goofy, so I don't like to do that. All right, let's see what we've got. Let's go through our verify first and see what happens. And then we'll pull out our full simulation. Okay. So first thing I notice is that my dynamic contour, I accidentally put a wrong number in there. And depths, yep. Negative 1.2. Check. Select that again. That looks a little better. Okay, so we got chamfers. I could probably bring them in a little more. I'm not going to worry about it for this demo. We went over that before in class. You can see here we got chamfers on all our holes. Everything there looks good. It's well deburred. Again, the only thing that we really didn't deburr was this here, which I'm not concerned about at the moment. Okay, so let's simulate this and see what we actually get here. So I'm going to go to Machine, and I'm going to go to Machine Simulation. Actually, first, I'm going to save it, just in case. Save, yes. Now I'm going to go to Machine Simulation, my little arrow down there in the bottom. I'm going to select my postability fixture. I'm going to set that up from a level. I know it's 21. Stock is going to be from MasterCAM stock definition. Post, use external post. We're going to use that in a second here. So I'm going to hit simulate. And it's going to bring our machine up. Eventually, hopefully our stock and everything else. Okay, didn't put our fixture on, so I'm going to come up here, do show fixture, and there we go. All right, so now we can walk through this, and I'm going to turn it down a little bit and hit play. That was interesting. The face mill didn't show up there. I'll have to take a look at that, see what's up with that. Okay. Just cutting that groove in there. All right, so what we're seeing here is it actually simulating what the machine, or I should say what MasterCAM thinks the machine is going to do. This does not take into account what our post has written into it. So in order to show exactly what the machine is going to do, or a lot closer at least, we need to turn use external post on. But overall, this looks pretty darn good. Definitely no complaint here about it. The one thing I do notice is that if you look here, it looks like my tap is hitting the bottom of this hole a little bit. So we do have to watch out for that. Probably want to change that tap depth or drill deeper. So that is certainly a concern, and we would address that. But let's go back and let's X out of here. And let's go into our simulation again, and let's turn on use external post and hit simulate. And now it is actually going to post the code. So this reposition feed rate value, I had the post written with a, anytime it repositions, it's doing a reposition feed rate, like when it dynamically mills and it does that back feed rate, that is a reposition feed rate. I'm setting what that value is here. So I'm going to make that 800. And should I use tool center point control and dynamic work offsets? The answer is yes, definitely. And now it'll... Okay, so you may get warnings when you use multi-axis linking. You get these warnings. Posted toolpath contains at least one large rotary tilt axis move. Basically, that's just throwing alarm saying, hey, it's telling it to make a really big and very quick move in either the A or the C axis. I'm going to hit OK. And then it's saying, do I wish to retrack, index, and then approach? In other words, rather than having the tool here and doing what it's supposed to do, the multi-axis linking is supposed to do, it's saying, do I want to retract all the way up, rotate, and then come down and approach? The answer is no here. I don't want to do that. That's why I put the multi-axis linking in there. If I wanted to do that, I would have never put multi-axis linking in. So the answer is no to that question. And okay, here, error, large rotary attribution encountered. Do you want to cancel to exit? No. I'm going to hit OK. OK, no. OK, OK, no. OK, wow, there's a lot of them in here. All right. So now it should come up, and it's going to use our post. And once again, my fixture's not on. All right, so now since it used the post, notice this. It is actually where it starts at. That's home, machine home. That's where its machine home is. So that's pretty normal. Now, I'm going to slow this down a little bit. Okay, so once again, it's not showing my tool. Oh, that's why. I didn't have tool on. There we go. So now it's going to come home. And it mimics exactly what the code shows. So it's sending my X and Y where it goes to for a tool change, how it always shifts to the back right corner, so that it can avoid smashing a tool during tool change into anything here. Safe tool place or safe tool change zone. And now it's coming down. We're milling out here. So let's see what we've got. Did my spring passes. Now it's going to do the finish pass and the spring pass around the outside. See here, it's milling, and you can't really see it right now. The graphics in process aren't that great. Once it finishes, the graphics are actually really good. Just changing tools, getting that 1/8 inch end mill, finishing that, changing tools again. So let me zoom out here. Oh, here we go. Okay, so it's saying we have a collision here. Do you want to continue? No, I want to see what's going on here. So I'm going to come in and see what's happening. That's interesting. So I think maybe it's just the tip of our drill that's colliding there. Kind of lost my place there. All right, so aside from that drill, everything else looked good. Yeah, everything else looks really good, actually. I can see all my chamfers there. Chamfers all look good. Again, my drill depths probably need adjusted. But I would feel good about running this part, with the exception of that drill. I want to take a look at that drill quick. I'm not exactly sure what the problem was there. I don't even know that there is a problem. So that was the first drill. Where was that at? Right here, I guess. Yeah. So that's this. And the tool, take a look. Yeah, I'm not sure why it's doing that. So, top of stock is right. Oh, actually, let me make this 0.4. I'm pretty confident that's not the problem, though. And let's repost this. Run. 800 point. Now it's going to ask about my rotary axes again. Do you know? Okay. No. Okay. Okay. No. Okay. All right, so I have no concerns about the first couple. So I'm actually going to go to next op, next op, next op, next op, next op. That's the 1/8 inch. Next op. Oh, that's the 1/8 inch. Next op. Next op. There's my drill. Okay. So I'm ready to play this. I'm going to play this slow. Fortunately, it's almost painfully slow until you get to the middle, and then it absolutely flies. Yeah, so I don't believe that that is actually colliding there. One thing I didn't do is create a tool holder for that. So I don't actually have a tool holder in there. That could be the problem, actually. Holder. And let me just make sure it's G81. Yeah, that's fine. Okay, let me see if that fixes it. Every once in a while you have a an error like this. So it's kind of good that this happened. You get an error like this that really doesn't occur in the machine because the kinematics aren't exactly perfect with the stimulation, but it gives you a really good idea of whether you're safe or not. And I would be confident enough to run this, and I would just be careful when I got to that drill. I mean, I'm going to be careful the whole time I run the first one anyway, but because I don't trust anything until I run it out there. So I'm careful the whole time, but when I get to that drill, I would just make sure I had everything on fire. I'd probably have the feed rate down when it started to come down, just to make sure, and I'd look at the code. I'd stop it before it actually ran it and look at the code, make sure the code looks like it's doing what it's supposed to be doing. But then once I ran that, I would feel comfortable, or once I looked at the code, I'd feel comfortable running it and seeing what happens. As long as I don't see like a G0, Z negative 5 inches or something crazy like that, you know, as long as the code looks the way it's supposed to, it's a G81, had a feed rate in it, it should be fine. Shouldn't have any issues. So that is now a tool holder. So I don't think that that's going to be the difference, but you know, you never know. And that was the difference. Huh. Ain't that something? So there we go. I just learned something there. I didn't realize that that would actually cause that. We're not getting collisions anywhere else. So just as FYI, hold on here, play. When it's running like this is why we make sure we pull the correct tool holder, because you don't want your tool holder to hit here or anywhere. You want to make sure that you have clearance. So essentially that's it. That is how you program for 5-axis, or at least, again, I should say 3+2. If we wanted to do these faces, we would just add another plane, and we would set up the plane the same way we did, with it orientated correctly. So it would be, you know, like this, X, Y, and then Z would be coming up towards you if we need to do something on that face. Luckily we don't, and actually that's not entirely true, because you are supposed to engrave Thaddeus Stevens on the front face. So you would actually be entering Thaddeus Stevens and putting it on this front face. So there is some more stuff to do here. So this is not completely programmed. You will have to do some stuff on your own when you move forward with creating this part. As always, if there are any questions, oh, before I go, actually, this simulation will only work on our NetHasp and, yeah, basically our NetHasp here at the college. So you will have to be here to use the simulation and the post. You can program with a default, you should be able to program with a default machine, but you'll have to change that post over once you get here and use the simulation. I will upload that simulator, and I'll help with, I should create another video later on about how to upload that stuff and get the simulator working for you. As always, if you have any other questions, of course, you can see me during class or during my office hours.